Okay, we are Team Grim Sweepers, obviously. Our project's a GoFer. On top of the computer. There it goes. First, we'd like to thank Weaver State's faculty and staff for their help, support our project. We'd also like to thank Roger, Ed, and Sean. Their company, Sheridan Technologies, provided us with the project and also funded our project, so we'd like to thank you guys and the staff. I don't think we could have done any of this without you guys. So, our outline of the project is the GoFer will be an adjustable, electric-powered sweeping tool that can go under the racks. It's to push any dirt, debris out from under the rack to the other side where it can be cleaned up. And this will reduce the possibility of injury and also give, not have to blow any debris out. And here's a little example of our GoFer in action. You can see it pushing the boxes out on the other end and side sweeping out and getting that little piece on the end. Let it go through and then after it comes back. Kind of the same action that the prototype already does. Oh, that's just the same thing over. Have to wait for code again now.
Well, we know how it works.
Now you know that. Yeah.
Okay.
The necessity of the project comes from in distribution centers, cleaning out of the racks is a problem for sanitation safety. The current system that most distribution warehouses use is they either have push brooms or air to get the debris out, which causes particulate matter throughout the building and also possibility of injury, especially the lower back. Some of the requirements in the design are listed right here. One of them is the width has to be adjustable from 48 to 120 inches. Maximum height has to be 6 inches, so it can fit under the racks. Some of these other ones, they have the ability to move for 2 people, so the weight has to be manageable. We have pull handles for movement, and these other ones, chainless drive system, battery power, UPS shippable, and interchangeable parts, ease of manufacturing, and strong for industrial use. Our goal is to design, manufacture, build a sweeping system that meets or exceeds the client's requirements. The system is to be designed to eliminate personal injury that's caused by mandatory sweeping under the racks. We've got, during the design process, we create a prototype and a finished product. The finished product will both be a heavy-duty version and a light version. Upon completion of the sweeping system, we would like to have our goal is to have a marketable product for Sheridan Technologies. We'll list now the responsibilities between each members of the group. My name is Derek Brown. I'm the team lead. We have Nick Peruka, who's our quality master. We have Brian Stoley, who's our production captain. Carson Robinson is our welding chief. Eric Clayton is our design czar. Justin Archibald is our financial guru. Chad Hampton is our executive secretary. And Kerry Tobin is obviously our faculty advisor. He's running the camera for us. The presentation will be broken down in the following areas. Justin will talk about the design process and cost estimation. I'll follow him by talking about the frame and the frame adjustment. Carson will talk about guides and drivetrain. Nick will follow that with side sweeps and front sweeps. Brian will then discuss drop-down casters. Eric will then talk about electronics and battery. Chad will then end with drawings, the lessons learned, and what challenges we'll face in the second semester. So now I'll turn the time over to Justin, and he'll talk about the design process and cost estimation.
All right, so I'm Justin Archibald, the financial guru. I'll just be talking a little bit on our process of how we started out our research on a couple of different main parts of the project, and then a little bit on the cost estimation as well. So this is a picture of the prototype that's currently functioning at the Genco warehouse that sweeps underneath the racks. This is where we took our first general idea from and went from there. We did brainstorm a few different ideas, different concepts for the overall design of it. We thought about maybe incorporating some sort of scissor lift that started at one end of the racks and then scissored out to the end, pushing the debris or boxes that were under the racks as it went. That was one of our ideas. Another of our ideas was to have a reel or spool on one end of the racks that then uncoiled and pushed some sort of broom or board across the floor to push the debris into the next aisle. That was another one of our ideas as well. But the idea that we kind of decided on was to stick with the design that was already built as a prototype, was the same that is already there, with guides on the sides and then drive wheels on the middle that just drove across the ground. At first, in this picture, you can see the general idea of having a telescoping frame that went across so that the width was adjustable, as well as some side sweeps on it, so that it would hit anything that we would miss just in the general aisle under the rack. We then went to this idea. You can see that we had the motor on board with batteries, and we had an electric cord on the motor at first that the operator would hold and then reverse or forward with the machine. Then we also talked about, on the general layout, having some sort of anti-sag cable that helped with the rigidity of the overall GoFer. But as we continued with some of our designing, we realized that wasn't going to be a factor and that we wouldn't need that. And so it kind of went more towards this frame idea and with the side sweepers as well, that would push in as it met a post or anything, but would be strong enough to push those boxes or debris that it would meet along the way. This is close to our final design layout of the GoFer. As you can see, we've gone from having the motor on a cord to some sort of remote control system, as well as everything contained on the motor, on the GoFer itself. And then this is our final design of the GoFer. Everyone else will talk about the individual parts a little bit later. One of our main ideas as well was to have a cart to help move the GoFer from bay to bay in the warehouse. We thought that we would need a cart to drive the GoFer up onto with ramps, as you can see there, and then with that we'd be able to move it from side to side. We continued. This is another idea that we had that would have eliminated the need for a cart, which we talked about a little bit earlier, with just some sort of push reel that would push everything. That was another of our ideas, and then also to have some sort of cart that was a hydraulic lift that the GoFer would come onto. We'd lift it up off the ground and then move it over to the next bay. But ultimately, we decided we pursued the idea of the cart more, where you just drive it up onto it and then move it over from the bay. And this is kind of our first idea, where we'd have a reel on the cart that was connected to the pouch that would reel in the GoFer as it came back, and we'd move it to the next bay. This shows the idea of that reel that would be used for the power cord as well on there. And this was what we were first pursuing with that cart, what it was going to look like. After looking at it, thinking, we decided to go away from that cart idea and go with what we're calling a drop-down caster system that would be self-contained on the GoFer itself, and we wouldn't need to move it, have two separate objects. So, and Brian will talk a little bit about that later. In our cost estimate, these are the vendors that we use to for the parts that we'll be buying. Mainly McMaster-Carr and Online Metals for our different parts and materials. And then Bison will be our motor that we're using, with a few others for electronics and the plastics that we'll be using on the card as well. In our cost estimate that you'll see in the book as it goes around, we have an estimated labor rate, as well as estimated fixed and variable overhead percentages, as well as an estimated make time. So the overall cost estimate will be a little bit inflated due to those estimates. When we can finally get parts in hand and start working on it, we'll have a better idea of the exact cost. But so these final prices that we have for the HD and light version will be slightly inflated due to the manufactured parts total price. As you can see here, just over $2,700 on the heavy duty version and just under $2,500 for our light version of the cars. I will now turn the time over to Derek, who will talk about the frame.
I don't know if anybody gets on. I'm the team leader, I guess. That's what I was referred to. I do like Mountain Dew, so I guess it's okay. As far as the frame goes, we needed to start off with a platform that was rigid enough to fulfill the requirement of being a rigid machine. We chose A36 steel square tubing for the cross members, which are these two pieces here. We did that to help with rigidity. We felt that the square tubing was the ideal cross members to use. In addition to giving us a rigid frame, it also gave us an ideal mounting surface for both the battery boxes here and here, the drivetrain, and the electronics. The first idea that we had was to have some sort of square tubing with a C-channel on the outside that would be adjustable, and we would throw pins through for that sliding adjustment. We ran into some problems with materials. Most companies that make the C-channel does not really mate with square tubing. So instead we found here, there's a square tubing to go with the sliding side of each other. The frame is assembled. You take the two cross members here and here, and you attach them. They slide right over these square brackets that are welded directly to the front and rear legs. This gave us the ability to break down the frame, which would help being UPS shippable, so we didn't have a large thing to try and ship. The legs on either end, here and here, they're also A36 steel square tubing, but they're perforated, and they are a purchasable item straight from McMaster-Carr for the intent of telescoping. So it did kind of take care of that need for adjustment. To help get rid of some of the sloppiness involved with that telescoping assembly, we did choose to put a PVC angle bonded to the telescoping slides themselves. This helped take out that excessive play that's we feel that's going to be present with that sliding assembly that's been pinned. The reason why we chose angle was we needed to be able to keep those bolt holes exposed, so that when the telescoping slides come in and out and you want to pin in different configurations, you're not having pieces of plastic that interfere. And PVC angle is a easy purchasable, cheap part. One of the requirements that was a little bit challenging was to be able to have adjustment from 48 to 120 inches. The reason for this is that most distribution warehouses can have different racking configurations with different widths. We felt that having the ability to have adjustment would take care of most distribution's needs. So we came up with 3 different configurations that the GoFer can have. The first one is that both guides are attached to the telescoping assembly. This gave us an 85 to 120 inches of adjustment in 1-inch increments. The second one is where you have one guide attached directly to the frame, and the other guide is attached to a telescoping assembly. This gave us a 49 to about an 85-inch width adjustment, and also 1-inch increments. And then the last configuration is where both guides are actually attached directly to the frame, and that gave us a 48-inch width to fulfill that 48 to 120 inches. So I'll turn the time back over now to Carson. He'll talk about the guides and the drivetrain.
I have a little frog in my throat, so I'll try and speak as loud as I can. In my opinion, the GoFer is a genius idea because there's no way to sweep underneath the racks just by hand. It's to use hand brooms or things like that. But one of the difficulties or challenges that initially was in play is that once the GoFer, the sweeping machine goes underneath the racks, you can't see it, and you don't know where it's going to go, and so there's no way to steer it, and you lose control. And so, in the prototype version, they took cross-country skis, which was a great idea, and cut them in half, and then had the curves come out this way, and then this way again. One of the difficulties with this is that it's hard to find cross-country skis that match and line up. These guys are smiling because they know, and so because they weren't always perfect and it wasn't always a straight thing, as the GoFer would go underneath the racks, it would actually hang up and bind, and so that poses the other challenge of trying to find a midget that can go underneath there and get it out for you. So it's not always possible. So what we wanted to do is to manufacture something that was consistent, that was straight, and there was no way that it could get hung up on the different rack sizes or if there was an offset in the placement of the racks. And so what we did is, this is the guide. This sits on the outside of the GoFer. And what we did is we took a piece of UHMW plastic, which has a very low coefficient of friction, and it's very durable, it's tough, it's not a shatter type plastic. And so this will, as the GoFer goes underneath, then this can just slide, and as it meets the separation of the gap where it's curved, then it can just span the gap and keep on sliding. And so you don't have to worry about steering it. You can just, it's basically blind, it can go in and then come back out, and you're not worried about it binding up or anything like that. Also because of just the span of extending out the GoFer, we needed to have a little wheel there. So we put a little caster wheel there to give it some support. And so this will also make it run a lot smoother as it goes in and then comes back out. We did 2 versions of this because we're trying to kind of cater to different shops or different packaging companies that would have different needs. And so this is a lighter duty or a kind of a shorter one for shorter racks for a company that would need, they don't have big spans or they don't have big racks. And so it's a little lighter weight, it's shorter, and so it's a little easier to store and whatnot. We also made a heavy duty guide assembly that fits on the same GoFer. The benefit of this one is that it's longer. It has an 80-inch length, so a company that has wider spans or wider gaps, this will just span it and go right underneath it. You don't have to worry about steering it. It can go in and out. We also added onto this this version as well as a way to fold in the ends for storage and also moving it around. Say you're finished working for the day, you needed to move it. You can fold in these extension arms down to 36 inches, I think, and then you can move it to where it needs to go. So simple, very straightforward, but I think a very genius idea to be able to steer this thing and not have to worry about getting hung up. The next thing I want to talk about is the drivetrain, how to get the power to the wheels to actually make it go underneath the racks and come back. The initial design had a chain-driven system that was connected to a shaft and then out to the wheels. Some of the issues with this is chain adjustment or possibly maintenance things on the chain, things like that. It would make it kind of, we wanted it so there was nothing you had to worry about. You just had to worry about sweeping and not have to pull this thing and maintain it once a week or tighten the chain or worry about anything falling down in between the chain and the sprocket and popping it off, something back. So to solve this problem, what we did was went with an actual hollow shaft DC gear motor. And what this is it's the housing for the shaft and the gears and everything. It's all pre-assembled from the factory. It's all closed in. There's no maintenance, no greasing, nothing. You just attach it to the shaft with a keyway and you're good to go. And excuse me. So at the ends of the shaft, there's two pillow block bearings that will attach on the inside of the frame. They bolt in very easily, and the motor attaches also to the inner frame. And you're good to go. No maintenance and very smooth operation, unlike the chain drive or posing any problem with that. I will turn the time over to you.
Alright, as you can see, I'm the quality master. That's going to be my job title. And I'm going to talk about the front and the side sweeps. So for this thing to actually clean and pick up some dirt, and one of the main issues it's going to pick up is broken boxes. They fall down, pieces of wood get in there, and they need something to get cleaned up. So I found these things online. They're called strip brushes. They have all sorts of different types of holders, as you can see, for all sorts of applications. We're going to use 3 of them on our GoFer, just for the different applications it's going to be used for. So this is the front sweep. As you can see, we just used the L bracket. It's going to hold the brush in. We're going to weld these bolts on, and it's pretty simple. Just bolt them on, and there's going to have little pockets in here. It's going to be adjustable up and down, so you can get it as close to the ground as you need. And as far as having it adjustable, we needed the sweeps to adjust with the frame automatically. That way you have one less thing to do. Just pull out the pin, slide it in, and the silver brush will adjust with it. The way we did that is we took that holder, and we're going to drill 2 holes in it, as you can see here. And you'll bolt it to this front leg, and as the leg slides in, it just goes through this little guide, little bracket, and so it can just be adjusted really easy. So one of the big issues we have is for the side sweeps. Now, as the GoFer goes under, it's just sweeping the area in front of it. It's not getting this little gap in between the bays. It's about a 4-inch gap, so we had to figure out something to do. We had quite a few ideas. It was really hard to pinpoint it. Here's a few sketches we have. It's kind of hard to see on here. Basically, there's a piece of metal that's curved, and it's attached to a guide, or a track, sorry. And it has a spring in there. So as the post goes across it, it just pops in, and then it'll pop back out. And then the brush is right underneath it. That's a side view, and this will be a back view. One thing about that, it was kind of complicated for the this application we're using it for. There's going to be a lot of moving parts, a spring on it. So we tried to get away from that, and we have this idea that has a little spring-loaded brush on the side. It has 2 gate springs that come from each side and go underneath the frame. And as it hits, one spring gets extended and the other one's collapsed. The thing about this one is you're having that spring get stretched out. I mean, it's going to get flimsy after time. So then, after a long day, went down to the saloon to have a few. Relieve the stress. As I walked in the saloon, the door hit me on the back, and the idea came to me. Use a double acting door hinge. Now, these are what you see on old Western movies. They just swing back and forth. They're really neat. They're adjustable, so you can have it really loose and it'll just go back and forth, or you can have it tight if you need it. They're also pretty cheap. They're about 15, 17 bucks. And this is the hinge. So as you can see, as the post comes up this way, it's going to push it back. and it extends right there, and then the same thing as it comes the other way. So what we have on the parts here is we have another strip brush holder, and with that all we need to do is cut it to length, drill 2 holes, and same with the brush. We're going to use an L bracket. It'll be easy. We just put it in the press brake, bend it up, drill 2 holes, and then we're going to attach some UHMW, like a cap. And that's the same stuff we're using on the guides with the low coefficient of friction. So as it hits that thing, it's not going to slow the gopher down. It should just slide back and insert through it. And then this is the actual model on the frame. And I forgot to mention that. How do you do that? Oh, not Captain. And then this would be a make part, a couple gussets and a mounting plate, and that would just mount to the frame. And that's it on the frame. And I'll turn the time over to the Captain.
My name's Brian Stoley. As you can see, I'm the production captain, Captain America. I'm going to be talking about the drop-down casters. One of the challenges we had was that we had to figure out how to get the gopher system from one pallet rack to the next easily. And as you can see earlier, this is Sheridan Technologies prototype. And you can see on it that it doesn't have a handle or any kind of swivel casters to move it side to side. All it can do is move forward and back. So they actually needed 2 people to run it. So once it came out from sweeping a pallet, one guy had to grab each end, lift up to go to the next. And with that thing weighing over 100 pounds, and then during an 8-hour day, you're putting a lot of strain on your back, and especially if you're doing it every day of the week. So we had a set of design goals that we wanted to meet or exceed. And first, we wanted one person to operate the gopher. That would save on labor costs because then you wouldn't need the second person standing around waiting for it to come back out to be able to lift it to go to the next. We wanted to make it easier to move from one pallet rack to the next. We wanted to decrease or eliminate strain on the back due to lifting, any kind of lifting or any movement towards it. And we wanted to incorporate the handle and the drop-down casters into one easy-to-use, function. And these are a few ideas that didn't quite work out that we had before. Justin kind of talked about the cart where it'd drive up and it would lock down, and then you would slide it over. But it was really bulky, harder to store, and we thought we could achieve the same thing on the gopher itself without having to build a whole different frame, and cost, and it would save us some cost and everything like that for all the extra metal that we would need to build that frame. And then this one is actually, sorry about the drawing, but it's a cam system that's actually on the gopher itself. That would, when you turn the cam, it would actually drop the casters down and take the drive wheels off the ground. And so then you could move it. But the thing with that, we couldn't really figure out how to incorporate the handle in with that cam system. So we thought we could find a different way that was easier to manufacture. So this is our final deal. We have the handle incorporated with the casters. Here's the casters. And how it works is you step on the step plate here, which will raise the handle up. And once you grab the handle, and then these 2 spring pins here and here will lock into the holes at a 90 degree. So you could then slide it over. And it has, it's on the 2 heavy duty hinges on the bottom. So it'll withstand the weight of it. And then this is what it looks like when it's up. And it meets all the height requirements for the 6 inches or the 5 inches that you guys are looking for. So it'll fold up nicely, and so when you store it, the handle and everything's on it and ready to go. And then to drop it back down, all you have to do is you have to step on the cable here, which will release the 2 lock pins, and then it'll just fold right back down. And then I'll hand the time over to Eric Clayton. The designs are, if I can look back in 40 years. The trigger.
Use the trigger.
Oh, the trigger. So I was mainly focusing on our electronics and our battery. What we were trying to figure out there, we knew that the prototype had 120 volt. It was plug-in. It either ran off of a converter or it ran off of just being plugged into the wall. We had a long power cord on that as well that they had to deal with. We were wrapping it up. When it went under the shelf, somebody had to hold that power cord as it went under the shelf, and they had to reel it back out as it came back. So there was some strain with that as well, dealing with the power cord itself. And then the other problem that you could foresee in other places was that most places don't have outlets, especially warehouses, on every aisle. So you'd have to either have a forklift with a converter, or you'd have to have an outlet in order to plug it in with the power cord. So we had a few requirements that we were looking at with the battery. One of those was a 6-inch height requirement. We know that some batteries, especially the last 8 hours, are pretty big. The 8-hour runtime, we also had an HD and a light version. So those are some requirements we were trying to work around when we were trying to decide what type of battery to go with. One of the first design considerations was a battery with a hand control. We thought we could just have the battery on the cart, and then we'd have just a pendant type hand control. Problem with that we ran into is we still had to deal with the long power cord. And we also found out that we were going to have to deal with some sort of power loss, especially running from a battery. We were going to lose that power going to the motor. So those were one thing with the battery and attached hand control. The other option would be the outlet plug, like I talked about. There wasn't any other problems with that one except for the power cord. And then there was a third idea that we thought, and that would be to make it remote controlled. That would solve our power cord issue. That would solve some other issues I'll get into too when we talk about hardware as well. Let's talk about batteries. There was a lot of batteries out there that we had to decide and kind of go through to figure out what was going to work. The best one we came up with was a deep cycle, a lead acid AGM, which the AGM is an absorbent glass mat, which means it's a self-contained battery. It can be mounted in any position except upside down. And you don't have any leaking problems. It is a 12 volt. That was based off of our motor, the motor we decided to go with. And the largest battery we could find within our design constraints was a 32 amp hour. And we also kind of looked into whether we could link those up in parallel or series, and I'll get into that a little bit more here as well. Big question was, we had that design constraint, but would a 32 amp hour battery actually get us our 8 hours with the motor we were using? So we went back to our what we learned in electronics. Found out that if we link two batteries up in parallel, it will not change the voltage, but it will change the amp hours. It will double our amp hours. If we did go with a bigger motor, perhaps somebody wanted a stronger motor, you could link them up in series. We do have enough room on our GoFer to fit two batteries. And they could be linked up in series. You would lose the amp hours, but you would gain 24, you'd have a 24 volt instead of a 12 volts. So you could use a little bit larger of a motor. So here's some of the options we came up with and their times. We had to figure out, we knew we had the 32 amp hours or the 64 amp hours, but we know that batteries aren't efficient. We know that motors aren't 100% efficient. So talking with some of the guys down at in the electronics, we came up with about a 70% efficiency. Motors are about 80% efficient at the best. And
we're going to lose some efficiency on the battery because we can't drain the battery completely. So we came up with 70%, times that by your amp hours, you come up with the total amp hours that you may get out of that, divided by the motor. And for the first one, it draws about 4.7 amps, and we get about 4 3/4 of an hours out of that one. Next one, if we double up in series with the 64, we're going to get about 9.5 hours out of it. So that will run an entire shift with the smaller motor. But we did some calculations. We did decide that smaller motor was plenty. It was a little bit bigger than the one that's currently on there, and that one works. That one works just fine. If you did go with a bigger motor, the 10.2 amp, you do lose your runtime, but you do gain a little bit of a more powerful motor. And then if you double up the batteries, you double that. Let's see. So our hardware that we were trying to decide when we were going between either making it remote control, after we figured out what the batteries were, we wanted to see if we want to make it remote control or if we want to make it just a pendant style with a cord. Some of the design considerations on that was we were going to have a hose reel, and that was going to have to be mounted to the GoFer itself. It was heavy, it was complicated. You still have the problem with the cord coming out, coming in. You still have your loss of power, and we found out that it's pretty expensive to get a power cord for the gauge. I think it was about an 8 or 10 gauge cord that we would need in order to not lose a lot of power as we go out about 18 feet. So we decided that RC was maybe the best way to go. And there was a couple of problems with this that we had to figure out, because I've dealt a lot with remote control cars, but you're not dealing with a 12-volt motor, you're dealing with just maybe a 9-volt, and they're small. So we kind of had to look into how to RC a 12-volt motor. And I started looking, I'd seen on TV these battle bots that they drive around. They're 12-volt motors. They're remote control. They use regular remote controls that you use on your everyday hobbies. And they actually have built speed controls that are designed for 12-volt motors. And you can plug your RC receiver right into them. They power the RC receiver, and they're powered by the battery, by 12-volt battery. They're cheap. They're just plug and play. And that kind of gave us, we had it just mounted right here with the RC receiver and the speed control, which gave us pretty much just an easy, simple thing that somebody can just stand there with a remote control device and drive it through. And that nice thing about this is this could be changed later on as well. It could be custom made. Right now we're just going to use an RC remote control. It could be custom built into your own type of remote control. So there's lots of design possibilities. Nice thing about this speed control as well is when you reverse the GoFer, it will actually charge the batteries. It's probably not a lot, but it is something. So it's kind of an interesting speed control that they designed. And it's cheap and easy, probably the best way to go. So I will turn my time over to our secretary.
Looks just like
How's this? I know what you're thinking. I can't pull off that hair. Okay, I'm going to talk about drawings, lesson learned, a little bit about what we can do next semester. To talk about the drawings, first of all, we went through a little bit of template creation, 3D modeling, and then obviously the drawings, and then we went through and revised them. So the template creation, we kind of went through that, and we decided on the size. First of all, we thought we'd do a D size and print them on B. Then we ended up in the end kind of all deciding that maybe printing them out on an A size would be best, just for paper purposes, and we thought that they were easy enough to be able to be seen. But it is nice that we have it available to be printed out on larger size sheets if that's desired. So then we formatted it. We kind of put different things in there so they kind of update. But looking back, I've actually learned a lot more about making templates, and I wish, you know, once you kind of have all your drawings there, you can't go back and change your template to, I don't know really how to do that. I wish, in looking back, I wish I would have set it up just a little differently so we didn't have to update so many drawings so often. So that was kind of one thing that I guess I learned from doing the templates and kind of working with every single drawing. I think on the HD version we ended up with 102 sheets, and you know, if you have to change something on every sheet, then you have to go through each one by one, and it's kind of a pain. So as far as the drawings, we're kind of lucky. There's a lot of us, so with everybody's help, everybody took a different part of the assembly, different part of the gopher, you know, whether it was the drop down caster, the guides, or you know, just cross members. We all took parts, made the 3D models of them, and then everybody kind of helped to do drawings. So it was nice that we had a lot of us. As far as being able to get all the parts we needed, we tried to organize it as best we could so that we could see that we weren't missing any parts or any screws, and we tried to put them in order as far as, you know, the way they would show up on a bill of materials. And luckily we had a well-organized team lead who was on top of things, seeing every single part that we needed and make sure that we didn't miss anything. In the end, you know, it's always important to revise, so we kind of printed out, we just printed out one sheet. We actually printed those on B sheets, and me and Justin went through them first of all and redlined them, and we took those over to Carrie, and then eventually ended up at Derek No Better Brown. That's what I call him, No Better. he was good at that. So then each, you know, we only printed out the one version so we could try and save on paper. So there's a picture of the other team members. So the lessons learned, we learned a lot about accountability, procrastination, and a little bit about customizing your parts. As far as accountability goes, we started out with just kind of, this is what we need to do. And I know the teachers especially hear this a lot, but especially accountability and procrastination. But as far as when we started, there wasn't like, you're working on this and you're working on this. It was just kind of, let's do this. So overcoming that, it was kind of in the end of the semester. Everybody, we eventually kind of saw the problem with that, and so we took the initiative of saying, you're going to do a guide, and you're going to work on this, and and so we all kind of had jobs, and with teamwork and hard work and Saturdays. I don't know if you guys want to sing with me. Saturday is a special. It's the day you get ready for senior project. Oh. Did you wonder who my singing leader was?
No,
I think Nick taught me how to sing, so you can ask him for lessons later.
It'll be short.
Yeah, we spent the last couple Saturdays putting in long hours. We all came up and just got it done, got what we needed to done, which leads me to the procrastination, which obviously, why do now what can be done later, right? I don't know who said that. I was pretty sure it was Derek, so I put his name down. No, I'm just kidding. He was the best one of all of us, probably getting it done early. But again, the way we overcame that was hard work and working together and putting in long hours. You just got to get it done. There's a little picture there for you. As far as the customized parts, you know, we have a lot of parts. You can see in the book we have lots of parts. We have tons of buy parts and tons of modified parts, and that's one thing that kind of took a long time. This is kind of a list of the different parts that we have on one of them, and that's found in those books. But it's you know, the more parts that you customize or modify, the more work it's going to be. So that was kind of one thing, and kind of something maybe for next semester is we'd like to consolidate some of that. We'd like to lighten the load. It's kind of heavier than we would have liked it to have been. So we'd like to lighten that. We'd like to, like I said, consolidate the hardware. We'd like the price reduction. Obviously, our price was a little higher than we thought it was going to be. But I know all of you know that as you try to make it lighter, it gets more expensive. It kind of is a trade-off there. So it'll be hard to work out that, but we'd like to see what we can do. We'd like to get her done earlier next semester, and we'd like to have a prototype made so that we can actually skipping the next one, go to the bottom one, the testing the prototype. We'd like to get that done so we can maybe even let the guys take it to their warehouse and try it out, see how it works, and then bring it back and see what problems there were, what issues we had. And then we'd like to assign specific tasks next semester. For example, maybe Karsten's our welder, and we have, different specialties. That's another good thing about our group, that we'd like to kind of assign those things out so that we're accountable for those. And I'll turn the time back over to Derek to kind of finish us off here.
Okay, all got through that. So, as you look at this animation again, this GoFer, any questions that you guys have, we'll start filling it right now as a team. So we're going to turn the time over to you guys for questions.
How much weight do you think you could push straight ahead? And how much weight do you think the little side clippers could push? And what size of it was a piece of board?
We're not exactly sure. I know you guys were able to, 5-pound boxes with the prototype fairly easily. I mean, there seemed like pretty full boxes, so I would assume that we would be able to at least push, a 5 to 10-pound box of candy. Our motor, compared to there's 170 inch-pounds or so of power. The one version is almost 200. The smaller motor, the larger motor is actually 478 inch-pounds. So, based off of, I think, requirements by that particular warehouse, you could actually tailor the motor to even do heavier loads if needed. So.
Can you explain what material you're using the wheels? So the actual gripping wheels that are going to be forced by the motor, what material is that made out of, and how are you going to keep those from turning together so it doesn't veer off while it's underneath there?
Well, part of the veer, we'll start with that one, is those guides keep it straight. So the guides are adjusted out to the width of the racks. So if it starts to veer at all, and this is an idea that these guys actually came up with, we just kind of took it and ran with it. But if it starts to turn at all, that guide straightens it out, and that was what their solution was, because they did have that problem before they put the skis on, if I'm not mistaken, right? And
I'll take the wheel one. The wheels are just a rubber material that we bought just a stock part that will fit underneath there with it, but it'll grip the floor as it goes. Just 100% rubber.
And for the drive wheel, we actually purchased a drive wheel. It's specifically designed to grip. It's got a keyway, so that it's not, designed not to slip. And it's just like you can get different durometers. I think it's a 70 durometer.
70.
Rubber.
To answer the other part of your question too, with the keeping the wheels straight, it's a hollow shaft motor, so they're being driven at the same time. There's no chance of one spinning faster than the other as well.
Yeah, I guess we should maybe clarify on the drivetrain a little bit. It's a 2-foot shaft with a full keyway in it, and they're locked into those bearings on the outside with the set screw, and then those drive wheels are actually locked in with the keyway and the set screw, and the motor is actually so the shaft goes right through all that, so it all is driven in one, so that one doesn't spin at different speed.
Call it live axle.
Yeah, live axle.
And I think as far as on the wheels, I think on the Bling version, there's spinners available if you want those.
Add-ons.
20-inch wheels on.
Yeah, we were limited to 4-inch rims, unfortunately, not the 22s.
How much does it weigh? I don't think I ever saw that.
Yeah, I guess we didn't put that up there. The light version that has the one battery, the smaller skis or guides, is just under 150 pounds right now. It's about 149 pounds. And this is obviously an estimate from SolidWorks. So it might vary a little bit. That was with using some aluminum, some 6061 and some A36 steel. The heavy-duty version with 2 batteries and the bigger guides are actually closer to 180 pounds. And we'd like to try and maybe get that down closer to 150 pounds. But that would probably take some material changes from steel to aluminum.
Mr. Karsten here. You mentioned that
Your ski's gonna be made out of UHMW, right? Polyethylene. Tell me some of the other choices you looked at and why you chose UHMW.
I was kind of with Derek, he's one of our plastics expert, and so I guess I could let him answer that.
Well, you can answer it.
Me answer it?
Uh-oh.
That's fine. We didn't look at anything else because that was, it was readily available. It could get cut easily and it had the low coefficient of friction. And so it was just something we decided to use. It was easily accessible. So.
Did you look at maybe, let's throw some else, Vasco nylon, Delrin, some
Yeah, I'll finish it off.
Teflon, I don't know, just.
Well, of course not Teflon. Too expensive, too soft. Glass-filled nylon. We thought with, well, personally, I thought with nylon, it's too hard, and when you're hitting a guide, you want some impact to be absorbed by the plastic. And UHMW does a fairly good job at that being soft. That's why nylon, and UHMW is still fairly cheap. So that was pretty much, I guess I made the decision on that myself. So, and then acetyl is obviously more expensive than UHMW. So, and a little harder to buy sheet stock of the sizes, the lengths we needed.
So I got a secondary question on that one. How are you gonna form it?
Well, it's going to be cut to length and then we go back to that.
Here, someone going.
Justin's the man.
Justin's the
We'll show up.
PowerPoint guru. This is for Rick. We actually had 200 slides, but we didn't want to talk about any of those, so we skipped through.
He can read those later.
Yeah, they're on the drive. You already know most of it anyway.
Basically, we're just going to order it in at the thickness and the height that we needed, and then we'll just cut it to length. And it's kind of hard to see, but we just needed to make a curve or a bend at the end, just to kind of resemble the cross-country ski that was put on the prototype version. And so we'll put a bolt in here, and then bend it, and to meet the hole that's drilled in there, and then bend it so it meets that curve, so we can bridge the gap that's left underneath.
And one of the advantages with UHMW is in that thickness, and I've already tested it, is that you can hand bend that in. So if you had the hole already there and bend it in, it's going to hold that shape because you'll have the bolts actually hold it, so it'll go like this. It may not resemble a good radius like that. That was just for fun, I guess. It might actually turn in more, but you'll still get that. And you'll actually have a gap, and some of that will take the impact. So if it's actually coming at an angle and it hits that end, it will deflect a little bit and straighten out. So that, instead of actually trying to heat form, you can heat form UHMW, but we felt like if you didn't bolt it, it will eventually either sag one way or the other.
How thick is that piece of UHMW?
Half inch. Which we might be able to reduce, that might be one area that would help us reduce the weight. It's maybe going down a little thinner. Any more questions?
I just had a couple. I just first wanted to say, this is a ton of work, and you guys have done a really good job. I think you have a lot of really ingenious design solutions to a very complicated problem. And you're really limited by a lot of different things. And mostly the place you're trying to operate, trying to find batteries that size that get under something that low I'd take my hat off to you. That's great.
And we can't take all the credit because we did bum a design kind of off of these guys as far as some of those things goes.
Yeah,
basics.
I understand, motor sizes and things like that came from something you looked at before, but your design looks significantly different than the one that I saw the photographs of.
Thanks.
Looks much more complex, but it also looks very robust. It's a lot of really good, I think that's a lot of really good design qualities. And I just wanted to ask you, I was kind of with George on the I always thought UHMW was really expensive.
It's actually not all that expensive. You're talking about maybe $7.80 a square foot.
Oh, okay.
So when you're at the 3-inch height is 36 inches, and these are obviously separate pieces on this version. It's actually fairly cheap, and you're really not going to see that much difference going down to just a high density polyethylene in price. Really
And
not
I'm,
that much.
I'm by no means the plastics guru. These teas at an industry, and I know that it is a good material and it can take
Yeah.
a lot of abuse and it's compliant as low
And part of the UHMW cost too that I was able to reduce it a little bit by actually a couple dollars a square foot is that we're going to use a reprocessed black, which cuts the cost down a little bit.
Ours was yellow, so maybe it was more expensive that way. It was
Anytime you have like just a virgin UHMW, it's a couple dollars a square foot higher in price.
And again, on the bling version, obviously there'd be flames.
yeah.
Yeah.
On your casters, you got a drop-down caster design for portability reasons, right? Have you sized those yet? And
Besides the actual caster itself.
yeah, as far as load capacity, you know how much it weighs approximately, right?
Yeah, we've got, they're actually, not this one, but the other ones are actually modeled already for us, and they're 150 pounds per wheel, so they should be
What
plenty.
kind of construction? Rubber
They're all rubber.
cast?
The cast rubber, I think they're like a 70 or 80 diameter, and they're full swivel.
What about mounting?
Mounting plate.
Mounting plate.
Pretty
For all
robust.
Four-hole mounting plate.
Yeah.
Something that should take a lot of abuse because I get the impression that this is something that's going to get the crap beat out of it.
So we did look into the stem
Heavy duty.
style, but we felt like having a full plate would be a little more robust. So.
Yeah. Just one last comment and I'll shut up. How do you feel about your workload going forward next semester?
I think we feel pretty
Yeah.
good.
Yeah.
It's gonna be a lot of,
That's nothing.
there's a lot of parts, but
Yeah, and that was one thing I was going to say.
Yeah.
If I were you, I'd look everywhere that I could to avoid modifying something that you buy, because the end user, when one of those parts fails, is going to have a harder time obtaining that modified component than they would just something that was off the shelf or the master car part number. So that could save you a lot of design time plus improve the quality of your design.
Yeah, that's one of the challenges I think we're going to face in the second semester is maybe trying to make it a little more purchasable,
Just
less
a little
manu-
brushing up.
Yeah,
No pun intended.
and we tried, and some of this stuff, some of the stuff we needed to try and do it to where we're not actually doing it. We were trying to do less welding and more just plain cutting.
I just was thinking about the little pieces of brushes that you have to drill holes in and things like that. Those are wear items, maintenance items, and
Yeah.
eventually they're gonna wear out and have to be replaced.
Yeah.
I think it's fantastic.
Well, with those brushes-
What's that?
Oh, sorry, with those brushes, they come out, the holders won't. The brush will
Okay, so
actually,
you just gotta
the
like.
brush will
yeah.
actually
Yeah.
slide out and
Yeah.
slide in, so once the brushes wear down, you just slide the brush out and then you can slide a new one in, so the holders will stay.
Perfect.
So.
One of the things that they did with this is realizing that it was going to be manufactured by other people. I didn't want them spending an awful lot of time in the machine shop milling and lathe work and things like that. Not that they couldn't do it, but that it would put more burden on the manufacturer later on. And so if they could buy something and not modify it much, that was one of the things that they were kind of directed towards in all of their design, and they've done a pretty good job with
Yeah,
that.
it's evident. It shows.
Can you tell me a little bit about your design review process or communications with the customer? How often you communicated, what it was?
Well, I pretty much did the communication between our team to these guys, and I would usually update. I probably didn't do as well of a job as I should have, is giving them more frequent updates of our progress. But I would send them JPEGs of kind of the things we designed, and we met multiple times. Met at the beginning. I went up there again after we came up with some more ideas. Then they came down here, and we spent some time going over some of our ideas. And then I'd kind of keep in touch, keep base with them. They would obviously probably keep in touch with me more than I was reaching out to them, unfortunately. But I would try to interact with them email-wise and in meetings, mostly.
So your guys' opinion so far?
Well, I personally, I mean, I see from our prototype initially to what's gone into this now, I mean, the professionalism and the design is far beyond what we would have even contemplated where we were at. You know, some cross-country skis and beat-up piece of steel. It's phenomenal. I do have a couple questions though, real quick. On the pivot points of the guides, is that how are you going to keep that true? Because, you know, from our prototype we found, and you even made mention of, where we cut the ski, they tend to throw it off a lot. So how are you going to keep that true when that clips back over?
Well, and this is me just thinking of how that, because I kind of thought about that when we put this together, that if we can keep, if the thickness stays fairly consistent and that mounting point, which those bases, they should line up fairly consistently. Also, we'll take one of the scrapes to put just a little bit of a bevel on each edge. And so even if it does catch, it's not a straight 90 degrees, it's kind of a little bit of a bevel, and you'll have it on either end of that to try and combat any hang up.
So based on the height at this point, the crossbar is not going to come into play on the rack, so your uppercut of the guide itself is not going to have anything to do with it.
Yeah, it shouldn't.
Shouldn't.
Because I think the skis they're not even a full 6 inches off the ground. Right?
No, they're that in between height we talked about needed to be above 5.5 inches or
5.5.
and under 6 in that range. So we should keep it under that. So it shouldn't hit at the top or the bolts at the bottom.
We talked a little bit about the speed. At what speed will that remote run that thing? I mean, is it going to go?
As far as the remote is concerned, it's whatever we set up with the motor. I think it's running at, what's the RPM of the motor right now?
At 15 to 16 RPMs, you're going to travel just under 22 feet in a minute. So about that span of your guys' racks in a minute's time.
And the remote, you know, that will just be the full speed of the motor as far as, and it actually will be adjustable from the remote. You could go slower if you needed to.
There's a speed controller, so
Yeah.
they'll control the speed, but the max of those motors, because they're geared down, is 15 or 16 RPMs depending on the two models.
To add another little bit of food for thought when we get back into this, one thing that you know, it's probably me and probably Sean a little bit I forgot about was once in a while you might get a box in there that actually falls crooked. What does it do when it hits a box like that at this point?
The speed control we have right now has a, God, the name just left me. It'll basically shut the motor off. If it has the amperage jumps, let's say it stops. So there is a protection in there so it doesn't damage the motor.
So at that point, you'd be able to just, if you want to retract it.
Reverse that.
Yeah, you could just reverse it.
Has there been any consideration to a bar of some sort that would automatically reverse it back?
Maybe that's something we could look at. I know we talked about that. I don't know if we...
We talked about it. We haven't really pursued the idea as much as we should have, but that is something we can possibly use as like an add-on. I know we talked about in our HD version with you doing some add-ons for different options, and we can, for our next semester, definitely pursue that idea of using it as an add-on.
And I would like to mention that I have looked into warning lights for the outriggers. Yeah, just at that so late by the time we started looking into that, we couldn't really do anything with it. But that's something we'll look into.
That was actually based on the thing coming out the other side.
Yeah.
If somebody was over there, it might scare the crap out of them. So, thought we put that on there. No, overall, I think you've done a great job, you guys, and I know we really appreciate what you've done. So.
Yeah, I think you exceeded our expectations. Phenomenal job from our standpoint. Great job, guys.
Any other questions?
How
You
far
want to
can
see
it go?
you want to see the GoFer again?
Without losing connection? connection to start RC.
The one we have is just AM, it's like a 27 megahertz, but I've got a car at home that's the same, and I can drive it to the end of the street, you know.
But if it's losing its vision underneath.
Oh, that's fine, it won't, it's all, I believe it's all FM, so it won't lose any, it's not line of sight. You can